And but as time goes on, the breed that we'll be having, will be the best breed that we can have in data science in the world. Yes, I want to promise us that after this training, we are going to have the best data scientists in the world as a product. So thank you very much and good morning. My name is Tejumola, and I'm glad to be your hand for today's section. Okay, we started on a good note yesterday, and we're going to continue on a better note today. I shared with you yesterday that I'm not going to be the only one who will be taking this section. I introduced to you yesterday my colleagues who will be joining me in paddling this canoe, okay, good, in captaining this ship. Okay, so for today's section, I'm glad to introduce to you my colleagues who will be taking the section. She's a data scientist, hands-on on vision, on computer vision. She has done a lot of projects in that regards. Okay, so please, I want you to join me to welcome onto the podium um, uh, my colleague will be taking this section, and is none other but Oluwatobi Omotowa. Please, a round of applause for Oluwatobi Omotowa as she comes to the podium to take the section. Okay, so over to you, Oluwatobi.
All right, good morning, class. How are we doing today? So I'll be taking over from Tejumola. Please, those online, can you hear me? All right. So before we start, let's do a quick recap about what we learned yesterday. Can somebody tell me the four types of ML? Anyone? Help us with the four types of ML. Machine learning. Yes. Yes. It was. Is that? No, it's a section. Sure. Okay, it's a section under machine learning, but the four main types that we talked about yesterday: supervised, reinforcement, and the last one. Yeah, excellent, excellent. So, what are the two major types out of those ones? Super. Can you tell me the difference between them? Excellent, excellent. That's nice. So good morning. I'm going to be doing something really quick. I will tell you like a problem, and you would give an answer with the algorithm you think it is. Is that okay? So for cancer detection, what do you think the algorithm we use for it? For cancer detection. Exactly why? So it's under classification. No, classification is under supervised learning. So what about customer segmentation? Customer segmentation. Okay, very nice. Then what about email spam detection? Exactly. So, all right. Let's move into the class today. And today we'll be talking about Python libraries that we use. That is very important for data science, which is NumPy and Pandas. Do you have it set up on your laptops? Hmm? Yes. Okay. Do you know why we use Python? Why we're using Python for this class? Hmm? And it's also very um, versatile. It has a large community, and it's very beginner friendly. Okay. I'll begin by defining NumPy. NumPy is a fundamental package for scientific computing and for manipulation of multiple dimensional arrays and matrices. So you use it to do computations in Python for your data science operations. Yeah. So to be able to use NumPy, first of all, we have to import it. We have to call it into our notebook to be able to apply the package. And this is how we call it. We use import NumPy. We use the function import to import and the name NumPy to call the package into our notebook. Can we all try this? Have you done it? Okay, Tolu is asking, how do we get the notebook? Okay, all you have to do is install Anaconda. Do you have it installed? Has everyone tried installing NumPy? Okay. So anytime we want to use NumPy in our package, we just have to call it NumPy, then call out functions within NumPy to be able to use it. But to make things easier for us, we like to shorten it. That's why we have this second line of code where this line of code here, where we save it as MP. Whenever we want to use NumPy, we just call MP. Can we try that? So now MP has been saved as NumPy. Anytime we want to use it in our code, in our notebook, you can just use MP. Exactly. So our first task today, we are going to be creating a one-dimensional array. How we do that, we first call NP, the package that we installed. Then there's a function within NP that is called an array. So we'll call that too. How we do that is np.array. Then we'll assign it into a variable called x. That will give us a one dimension. One dimension in the sense that it just has one row. If it's two dimensional, it will have rows and columns. So to do that, we'll try this. Try this first line of code. Have we all done the X section? Okay. What do you notice about this? That X. Yes, it's a list of numbers. But that list, the way we've packaged it, makes it one row. Sorry, one column of numbers, making it a one-dimensional list.
So does a column determine the dimension?
Yes, if it's one column, it's a one-dimensional. If it's two columns, it will be two-dimensional. Because then we will have row and column, making it a 2D. So multi-dimensions will be more columns. So how do we check the shape to know what we just created? How do you check? We use shoulders. You use x.shape. Exactly. We'll call the function shape. Can we try that? Have you gotten our result? So from what we see, what did we all get? 5. But if you notice, we have comma, which means the first word is representing the x-axis, which means we have 5 rows, but we don't have a column yet. Then the second one too, we also got 1 row showing that we have 2 elements in that row. Please, are you getting me?
Yes.
Okay. Let's move on to creating a 2D array. Before that, what do you think we'll need to do to create a 2D array? Exactly. We'll create the x and the y axis. Can we try that now? How many of you knows how matrix work? So can you tell me how it works, matrix?
Not entirely sure.
Okay. Matrices is like an array of numbers and expressions arranged into rows and columns. So yes, that's exactly what this is. So this is kind of like doing matrix here. So have we done this?
Yes.
Okay. What were the answers we got?
The shape of Z
We
is
got it 2 by 2. So means in language of matrix.
two-dimensional
Dimensional. Yeah, and also 2 by 2 matrix. Okay. Ayomide, is that fine? Now let's move on to creating multi-dimensional array where we have multiple columns between 3 and more. How do we do that?
So these are multiple columns and multiple rows, right?
Is that?
These are multiple columns and multiple rows, right?
Yes, we have 3 rows and multiple columns here. The elements in each list represents the rows. Like now we have a list within a list.
Yes.
So the main list was the first list here. Let me highlight this. This first list is to set out the amount of columns we have for the x-axis. And to have this, we have 1, 2, 3, 4. Looking at this, what do you notice here? We have one list here.
Yes.
We have another here.
Yes.
We have another here.
Yes.
So that means there's 3
Columns.
No, there are 3 matrices here.
Mm.
So within this matrix here,
Yes.
we have 3 columns. Then within each one, we have 3 rows.
Mm.
This low one, we have 3 rows. Let me explain that to those online. Guys, we have, if you look closely at this code, we have 3 matrices within this list here that have been segmented. The first one is this one here, where we have 3 lists, 1, 2, 3. And within each list, we have 3 elements there, making this a 3 by 3 matrix. This one alone, making it a 3 by 3 matrix. Then here also another 3 by 3 matrix.
So
within this list, we have 3 lists, and within each of these 3 lists, we have 3 elements. So our results, when we want to see how it looks like, this is what we'll get. Can we run this? Play around with it. Can I? Scroll. Okay. Ogunde, where are you having issues with? Rashida is correct.
well, this is 22, 23, 24, 26, 27, 25.
Yeah, because we're just using
Random numbers.
random numbers. How many of us got this as our answer? How many of us? Olusesi, well done. That's good. Anyone else? Okay.
It makes more sense when it brings the shape. It's
Yeah,
more
understandable.
It
Yeah.
looks like mattresses now.
Let's try something. What if we make this one a 2 by 3? Yeah, we add one more figure here. What do you think the result will be? Is that? Why is that? Exactly. So the number of rows has to be the same. Are we on page
Yeah.
up to this point?
Yes.
All right. Let's move forward. I will discuss the functions that are stored in NumPy. So we have functions, built-in functions like arrange, reshape, line space, and full. Then also random to pick up random numbers. This helps us perform processes within NumPy. Within data science to make our data sets presentable. Can we try some of this? How they work? Let's try working with arrange. Those online, please, are you following? Okay. All right. Are we ready to try how arrange works? All right. So what arrange does is randomly create a 1D array for you with
Randomly creates what?
it creates a specified range of values of a 1D array for you. So now we want to create um, a 1D array with 10 elements in it.
So is it empty?
MP. It's not empty. It won't be empty.
See what's in there?
You print out okay, let's try it.
Oh, I see.
So that will bring us the list that it has created for you. But shape-wise, it's a one-dimensional array. Do we all get this? Moving forward, please call me go back if you don't understand anything. So we want to change, how do we change a scalar matrix into a vector? That's what we're going to learn now. We use the function reshape to change the shape. Let's create, let's try this using the 1D array we already created earlier and apply reshape to it.
Looks like it's not more one the array when you're shaped.
Is it?
It's not more a one the array when you're shaped.
Yeah. It's no longer a 1D array after
This
shaping.
is 2D now.
Yes. Okay, Shekina is asking what a vector matrix is. So a vector matrix is like a column matrix where like it's a matrix with only one column. Where are we now?
Switch to single column array. This column matrix vector.
Okay. Have you tried it? What did you get?
The shape of the one. It switched to single column.
To a vector.
Yes.
Something like that, but transpose works in Excel. Miracle. Is everyone clear on this?
Yes.
So, can you share like the parameters we use for the network, the change network?
Okay.
Yeah. B minus those.
Okay.
Parameters. Why?
So that first line of code that we see there, it has a reshape method that will change the shape of the A10, which is just a list, a 1D array list. So then we now have We now have the minus one. This minus one is like a placeholder in reshape to change the direction. So it tells NumPy to automatically calculate the size of that dimension based on the original array. So if it was 10 elements here, to switch it to 10 elements down here. Yeah, like transposing it, but in Python, how we do that? No transpose, we do that in Excel.
Yes.
Then the next line, we are printing it out. But to make it more legible, we put a space between it. Space to space it out. Then we now print out the P1, the result of what we just did here. Is that clear? The minus one. How will I? You know, in vector, when you put minus, it's in the other direction. So the plus will be positive here, minus will be in the other direction. So you are changing the direction of the array.
So when I what do we change that one? The y coordinate to the three. Instead of one. We change it to one.
Let's try it. What to give us?
Cannot reshape array of size 10 to shape 3.
Have we all tried it? If we change that 1 to 3.
But 2 works. Yeah, 2 works. Yeah, 5 works.
Why do you think 2 works? It is divisible by 10. 4 2 is divisible by 10. So to change it based on that. So if we use 3 minus 1 3, it won't give us an answer because it won't be equal, it won't be complete. So do you get it? Those online, do you get it? Please respond. Yes, we can use 5. Try it. Are we on page now? Okay. So let's move on. So for activity, let's try and reshape B into let's try this here, two-dimensional array.
So, excuse me. This is basically saying 2 rows and 5 columns.
Yeah. Okay. Those online, can you hear me now? Okay, great. I said we should try this out. Reshaping. We want to reshape B10 that we've created here. Right now, it's a 2D array of 10 rows, 1 column. We want to reshape it into, yes, into 2 rows, 5 columns. Has everybody done that?
Yes.
Any questions? We need to note that the new dimension that we created must be compatible with the old one. So moving forward, now we want to create an array filled with zeros. How do we do that? To do that, we call in the zero function within NumPy. So that one is to create a matrix of zeros. Here we want to create a 2x3 matrix of zeros. Can we try it? Hero Chris, that is very good. It's a 2D array, Damilola. Have we tried creating the array?
Yeah.
What did we get? It's bringing it out as a float. You specify int.
It's a matrix of 2 rows and 3 columns.
You can try it in any dimension you want. 5 rows, 10 columns to bring out results. Let's try it. Okay. It gave you an error using int. Okay. Let's try it on screen. Here you see it gave us an error. And the error message says we cannot convert non-string with explicit base. Now to be able to do this, because this is in NP, NumPy package. If it were in normal Python, it would have worked. So what we'll do now is to call in a function that will be able to accept the data type we want it to be. So that function that we'll be using is AsType. We use AsType when we want to call in the specified data type we want to convert it to. So let's try it now. Zeros which means we want to assign a new data type to what we have. Have you tried it now? What did you get now? Are you still getting an error? Do you get it now? Yeah.
So I didn't get any error. Like I got an output without the hashtag.
You got integer.
Without
Integer output.
yeah, without
The as type.
the hashtag.
Where did you put the as type? Where did you put the integer?
Everything literally the same. Yeah, I didn't add just hashtag. I got an output.
You.
Yeah, I didn't get.
Oh. The answer is true. Yeah. No.
Yeah, okay, because
If you
there
want,
was an
if
error
you want
message.
what we're doing now is converting that code into an integer.
Okay.
If you decide you don't want it to be in float, because float is the data type that it's inbuilt with. Do you all get this so far? Okay, can we move on?
Yes.
How about when we want to create an array filled with ones in it? Still the same, yes. We use MP. We call it first calling the package MP, then we now call in the function within that package that does what we want once and specify the attributes that we want, specify the matches we want, 2 by 3, 4 by 3, anyone. And you print out an output. Can we try this? You don't have to follow it exactly like this. Like you can make the attributes different. Please, those online, can we see the screen? Do you have any issues so far? Okay, moving forward. If you're Anne, if you're okay with it being a float, with your answer being a float, you don't have to call as type. As type is the function within NumPy to change the data type. Like right now it's from float. If you want to change it from float to integer, you have to call in the function as type first. So if you want to change it, go ahead. Okay, so now we want to create a 2D array with any number of our choice. And this is how we do that. We will use the function foo to achieve that. we use the function foo. Then for the first attribute, we'll be specifying our matrix that we want. Right now, this example shows that it's a 2 by 3 matrix. We put that in. Then the figure we want it to be. If it's 4, if it's 5, if it's 6, figure we want within our matrix. The elements we want in our matrix, we specify that as the second argument. Can we try this?
So this only creates one number.
Yes. It's like creating an auto-generated matrix. So if you want just one number, if you want 0, if you want it to create a dimension for that. Is everyone on page now? Okay, can we move on? Let's create a diagonal matrix. The function we'll be using to create that is the I function. Yes, I function. Imagine we make this a 6 by 6 matrix here. Can you see? Gives you the diagonal matrix. Any question? Let's try this out. Okay, Damilola, you're asking for the relevance of diagonal matrix. So you can use it for efficient representation, where we have a compact representation of our matrix, and we use it in solving systems of linear equations. We have a linear equation that you want to solve with Python. You can use this function for it, depending on the task you want to accomplish. There are functions. I'm showing you the functions that can help in achieving that. Have everyone done this?
Yes.
Can we try creating a diagonal matrix of 3 by 8? Rashid, that's correct. Like, so we use diagonal matrix to solve for eigenvalues and eigenvectors. Have you gotten your answer?
Yes.
Convert it to integer. Everyone online, convert your diagonal matrix to convert the data type from float to integer. What if we want to create a list or a matrix of evenly spaced numbers? We use something called line space, the function called line space. So based on the parameters you give it, like now, if you want to create a list of 10 elements and you want to space it out, equally spaced out elements. You want 6 numbers. How will you do that? Can we try it? Using line space. You know how we call functions in NumPy? Then we insert our parameters within. Have we tried it?
No.
We want to create a list of equally spaced values. I want you to use like between 0 and 10. Between 0 and 10. Using line space, the function. If you get errors, it's fine. We'll treat it together. Michael, is that fine? Or I should still scroll up? Okay, I can see those online are already getting it. Have you tried it? Do you get errors? Okay. Did you get something like this? What was the intervals it gave you? And it gave you evenly spaced. Okay. The last number to specify it should be evenly spaced, but the last number will be used to specify how many elements you want. So it will make it equal based on if you ask for like 6 elements, it will calculate 6 equally spaced elements. If I ask for 8, 6, it will equally space it. Can we try this in 5 elements? 5 numbers. We want 5 numbers equally spaced between 0 and 10. Can you see what we have?
Yeah.
Let's move on. Rashid, we wanted to create a line space. We wanted to create a list of numbers that are evenly spaced between 0 and 10. So we had to, which we've already done, but I explained now that if you want to control the amount of elements within that list, you can specify it using numbers attributes. Do you get it now? Which is what we have here. The number here controls the amount of elements we will have in our list. Do you get it now? Yes.
And that norm there is constant.
The what?
The norm.
Number.
The norm.
It's a parameter you can use to specify the intervals you want.
But the interval is 2.5, not 5.
The number of elements.
Yeah, 5 elements.
So 5 elements, which means it will create an interval that will accommodate 5 elements.
So that's a feature. The software determines whatever the value is and divides it evenly. But I think what he was asking was something else.
Yeah, what was that? The norm.
The number. You can change the number.
Not the number. That's those words.
The norm
Yeah.
is a parameter. Yes. Can we move on now? Okay. Let's create a random array using, and this is the value we use, the function we use, the random function. So functions like linspace, I, ones, zeros, array, and random. These are the major functions within NumPy that we use for computational numerical computations within Python. So let's try this out. Let's create an array filled with random values.
Can we determine the range of the random?
Yes, you can. You can specify the range. Let's try this out. Have you all tried it?
Yeah.
Now, the first line, we use it to generate random samples. Random samples of lists using from a uniform distribution between an interval of 0 and 1. So it gives you, the way we specified now, we asked for 2 by 3. It will give you a 2 by 3 matrix of numbers between 0 and 1, random numbers between 0s and 1. That's why our results here, we have this. It's 2 by 3. You can see they are all within 0 and 1. Yes. Now this second line, to shorten it, they both do the same thing, but to shorten, instead of using random samples, we used rand instead. It's still going to generate the same thing, but short, a shorter function. Let's print out X.
So X is a 5 by 3 matrix.
A 5 by 3 random matrix. Random integer matrix. Do you get it? You said? Yeah, rand integer. It's for calling, generating random numbers, random integer numbers, instead of the float. Instead of the float. If you just use rand alone, it uses the default data type, which is a float. To store the values, we are storing it in the variable x. That's why we created the x variable. Then the first one we stored it in MP rand. The second one we stored it in MP rand 1. We assign those random variables to those random samples into this variable. Zero zero.
different times. When we run it at different times, generating different, since the random.
Yeah, it's random.
But in every case, mine is generating zero. So just X is NP dot random dot eight. Okay.
If you want to save, this generated samples so that it won't change every time, you will try this. That's the name. Oh, MP run.
Looks like it takes two arguments. The first one is a comment. First one is name. The first argument is a string. If you say first argument is a string and second argument is an empty rand. So this string empty rand
argument files. Okay. We didn't specify the name of the file we want to save. So we need to specify the name.
So we're going to save this as a file.
Yeah. So let's call it array data. So let's call it round again. Okay, round.
We have the same exact thing.
Exactly. So to save the question you were asking, to save it generated the first generated to save the first generated random numbers that will assign to this variable nprand, because if you keep calling nprand to keep generating new random numbers, but to save what the value we have there, we have to use the save function, and it takes in two arguments: the name of the file folder that you want to save it into and the content you want to save. Is that okay?
Yes.
Those online, does that answer your question? Okay, Henry asked, np.save is to save a function or save something. So what we want to save is the np.rand that we created. Here, this line of code. We want to save it so that no matter how much we run this code, it won't keep on generating new random values. So we saved it into this file, array.data.mpy. That way, no matter how much we call in np.rand, the values won't change. It will remain the same as the first one we've generated. Can we move on now?
Yes.
Okay, let's move on to accessing elements of NumPy array. Chibuke, let me see the code you used. Can you paste it on the chat board? On the chat? Chibuke, you said you have issues. Do you still have that? Let me see the code you used. Can you hear me? Have you been able to save? All right. Let's move on to accessing elements of NumPy array. Are we all together? In order to access an element into the array, we have to specify an index. This works in list of lists. So we need to specify the index within that list for both the rows and the column. So let's try it out. This is a one row, one column. Oh, sorry, it's a scalar. It's a scalar matrix. First of all, let's print out what Z is. So this is what we have here. This is a 2 by 2 matrix. So we want to call in the element 3, which is in the second row. No, in the second column, but the first row. The first row of the second column. So how do we do that? The index. The row starts, we are using index from 0. First column. But if we want to get the index of it, what will it be? 1, 0, exactly. So to be able to call this, we have to use the index. An index starts from 0. So this, for the column section, this column is 0. This column is 1. So that will be, our column will be 1. But for the rows within, the elements within the list, 0, 1, 0, 1. So we are calling 1. We are calling 1 on the x-axis, which is our row.
If we're calling 1 on the x-axis, does that mean 0 is?
We are calling 1 on the x-axis, which is this one.
Which is the second row.
Yes. No, 0, 1.
Yes.
Then
First column.
we are calling.
Yeah, that's the first column. The first column is 1 and 3.
Then first row, second row, first row.
Okay, let me show you what we're seeing here. This is basically what we're seeing here. Row 2. So within this column, this is the first list. Within this first list, there are 2 elements within that list, 0, 1. So that is the one we are picking out for the first section. Then within that one that we've picked, we are picking the first element within that list, which is 0. Yes, and that's 3. Is it clear? So how about if we want to pick 4? What will we use? 1, 1, exactly. Hero Cruise. Which part are you not clear about? The one we just finished. Okay, so look at it this way. You know, this it's showing like a matrix, but if we spread it out, we have a list within a list here. The outer list shows that there are 2 elements, this and this. So the index of this element is 0. The index of this element is 1. So we are trying to call out, we're trying to extract 3, call out 3. How do we get that? First of all, we will specify where, in which element is the 3 in. It's in this second element, which the index is 1. We'll call that 1 first. Then within this list, because this is also a list, within this list, we now have 2 elements within, 0, 1. That's why we are calling 0, because the index of 3 within this list is 0. Do you get it now? So if we want to call out the 4 in this list, 4 is within the second element in the outer list, which is 1. Then within this list now, 4 is also the second element, whose index is also 1. So let's move on to, you have a question? Z, it has already been created earlier. So we are calling it now. That's why I printed out print Z for us to see. This is Z. This is the element in Z here. We've already assigned this matrix into Z. So we are calling out elements from it.
I think Z was assigned when we were creating 2D matrices.
Matrices, yes.
It's right there. Just print it. Oh, if you guys took the notes, it's right there.
You can create it now. Okay, let's create one here. Let's call this Y. Okay. We are creating a 2 by 2 matrix now. Let's create a 2 by 2 matrix. First, what's the first? Can anyone remind us what's the first step we need to do? Exactly. So we'll assign it to. No, you already have Z. Let's call it something else. Let's call it P is equal to MP dot array. Then you specify the matrix we want.
1, 2, 3, 4. What's after this?
Yes. Then we create an inner list.
Well, that's a dictionary. And then the inner.
So inner, so 1, 2.
Then 3 and 4.
Then
Up. Yeah, there.
3 and
3 and 4.
oh P. see that now? Okay. This shows the other ways we can also do the same thing. This will bring out the first, we bring out the second list, and this will bring out the first element in the second list. All right, can we move on? Because of time.
The code is based on the slicing thing. It's kind of along with the code. It's kind of confusing.
You're talking of you're talking of this one. Okay. So this slices through the first element in Z, creating a one-dimensional array. So from here, we'll slice out 1, 2. Then the first element in that one, the 0, stating the first element. That's why we have 1 here.
Row 1, column 1.
Yes, row 1, column 1. But instead of bringing it as row 1, column 1, it's like cutting this this matrix in two and extracting this one. Then bringing out the first element within that. That's what we're doing here. Is that clear?
Yes.
Let's move to attributes. So array attributes reflects information about the array itself. So if you want to learn like you want to know more information about this, you know that this is an integer. You want to display that, you can use data type. So the function is dtype, and it's used to return the type of elements in that array. So if it's an integer, if it's a character, it will tell you that. Or a float, exactly. You can hear me? Oh, okay. Then size will return the total number of elements within the array, and the shape, you already know what shape does. I said array. Rashid, I said array displays more information about the attributes. Attributes, a number of attributes. They display more information about the array. If you want to know more about the array that you have, or the elements in the array, you want to get information about it, like the data type, the size, and the shape. Yeah, there are functions you can use to get that. And the first one we're using here is data type, where it tells us it's an integer. It tells us x is an integer. The next one, we already worked on how worked on the function shape. It tells us the dimension. Then the size tells us the number of elements within that array.
So what does that count? Columns and rows? The total of columns and rows?
Total of elements within the rows, all of it combined together within the entire array.
Okay.
Rashid, is that clear to you? So can we move on?
Yes.
All right. We already know how let's transpose a matrix. We learned how to do that earlier, didn't we?
Yes.
We can use a shortcut. Well, we use capital T instead of the one we were using before.
So that's x of t.
Yes, it changes the direction too. Okay. I think my time is up, so I will stop here for today.
So we'll start with pandas tomorrow, right?
Yes.
Okay, thank you. I want to believe that we have all learned a lot from our facilitator for today. To attest to that, I want those online to use their favorite emoji to celebrate the facilitator for today, and those of to give our facilitator a round of applause. Okay, thank you very, very much. Yes. Wow, that's awesome. This is actually a testament that our facilitator has delivered. That's what we expect because we know that we not give more than excellent delivery. You know, I always say that at DSN, one of our core values is excellence, and we always try to make sure that that shows in everything that we do. Okay, so as we call it a day for the Python for data science section, there is a short information and important one that I want you to be aware of. And we are celebrating some awesome set of people. And I want you to please be attentive as we make this announcement. So I'll be sharing my screen now for this update. Okay, can you confirm you can see my screen? Those on site, I don't know if a support can be given so that they can see my screen. But I'm very sure those online can see my screen. Okay, so as we set up for those on site, let me just quickly give the update. So we are celebrating some awesome set of people on Friday. I don't know who can guess. We are having an international celebration for some set of human beings on Friday. I want you to, if you know those people, can you just drop a chat? You know, the people we are celebrating on Friday internationally. If you can just guess it out before I change my screen. The women, good. Please a round of applause. We are celebrating our women. And at DSN, I told you, it was introduced to us that we are inclusive. And because we are inclusive, we dedicated the whole community for women. And our ladies in Hey High community will be hosting an event. It's a physical event here at Alagomeji, DSN AI Hub Alagomeji. As you can see on the screen, my colleagues will also be dropping the link to join this, to register for this. So if you are in Lagos, this is the most attend event for you. We celebrate all the women, the international women, and then we have lined up facilitators that will be helping us on to celebrate women. Okay, so can you see this? We'll be having as one of our facilitators, Dr. Adekemi Omo Tubora, and we're also having an expatriate who will also be joining her to celebrate the International Women's Day. Please, I want you to be available whenever. So far, we are in Lagos State, and you can find your way to the hub here. Just make it a call of duty to be here, and let us celebrate the women together. So thank you very much. The next session will be starting in the next 30 minutes. So let us, those that are waiting for the two sections can just wait, and those that will be leaving can leave, and we are expecting some to also join the next session, which is for data analysis with Power BI. So thank you very much. Thank you all for joining this section. I'll see you tomorrow as we continue on pandas and also data preprocessing and data visualization. It's going to be a packed one for tomorrow because we need to cover those topics. So thank you very much, and do enjoy the rest of your day. Okay, bye-bye.
To drive inclusion, accountability, fairness, and responsiveness of AI models.
My expectation for this workshop basically is to learn, some of the best practices as regards, the AI system.
How to use AI, that's artificial intelligence, to strategize into what I do, which is data science.
You're trying to deploy a system across, let's say, different geographies, then you don't just want to rely on historic data for a particular geography.
AI is now in our faces. It's something that we now use daily. So it means that even as a user, you have to be responsible.
I'm trying to start this my new journey with DSN. I'm hoping that I start on a very great level.
How you use AI also matters. Are you using the AI for what it's meant to be used for?
To be the best, number one and nothing less. Lead me to my destiny. I have waited patiently.
Ladies and gentlemen, and the winner is DSN Data Science Nigeria.
On me, so stand up for the champions, for the champions. Stand up, stand up, stand up. For the champions, for the champions.
Congratulations, DSN, on winning the AI ML Excellence Awards at the AOT 5.0 Awards. We all want to say, congratulations!
For the champions, stand up. Stand up, stand up, stand up. Here we go.
Congratulations! Congratulations, DSN.
It's just like that.
Congratulations, DSN.
Have our strengths and weaknesses. Oh, I have vision, can't you see? I'm on the move, make way for me. So stand up for the champions, for the champions. Stand up. Stand up for the champions, for the champions. Stand up for the champions.
Congratulations to DSN.
I have to pick myself back up. And when I fall down, I have to pick myself back up. And when I fall down, I have to pick myself back up.
You did it.
Stand up.
Congratulations,